Today we will talk about few other important endocrine glands. Pituitary is the master gland, and you know that hypothalamus controls the pituitary gland. Pituitary gland controls the other glands, endocrine glands of the body. One important endocrine gland is the thyroid gland, located at the lower part of your neck, here, front of the neck. And thyroid gland has two lobes, two lateral lobes like this, and they are connected by isthmus. Okay, and these are called lateral lobes. Okay, so two lateral lobes connected by an isthmus. And if you see inside the thyroid gland, you will see many follicles, like finger-like structures. So the thyroid glands are heavily filled with the follicles like this. Okay? Okay. Now, if I make a cross section like this, slice, and see under the microscope, what I will see these follicles, right? So these are the follicles. Okay, so these are the follicles. And in the wall of these follicles, you have the cells. These cells are called follicular cells. So very simple. The wall of the follicles, you have the follicular cells. And in between the follicles, you have another type of cells. And these cells are called parafollicular cells. Okay? And follicular cells and parafollicular cells produce two types of hormones. Follicular cells produce T3 and T4. T3 and T4. Triiodothyronine and tetraiodothyronine. Tri means what? Three, right? So triiodothyronine is the name of T3. Okay? Now if I ask you, how many iodine atoms are present in triiodothyronine? Its name is telling you, right? Triiodo. That means how many iodine? 3 iodine atoms. Okay? And in tetraiodothyronine, which is T4, tetra means 4, you know that? So how many iodine atoms? 4. Is it clear? So in T3 you have 3 iodine atoms, and in T4 you have 4 iodine atoms. Okay? So now you know that for T3 and T4 you need iodine, right? That's why you need to take iodine. You know, iodinized salt is important, right? Your body needs iodine. One reason is this: to produce thyroid hormones, T3 and T4, you need iodine. Is it clear? Okay. And parafollicular cells produce another hormone that is called calcitonin. calcitonin. Okay. Now, if I ask you what are the important functions of T3 and T4, triiodothyronine and tetraiodothyronine. T3 and T4 are mainly responsible for the cellular activities, maintaining the metabolic activities of the cells of the body, metabolism. Okay? So T3 and T4 regulate the metabolism of the cells. Very important, right? Cellular metabolism. Calcitonin. Calcitonin is responsible for lowering the calcium in the blood, reducing or lowering the calcium in the blood. Now, if T3 and T4 secretion increases in your body, metabolism will go high, right? Will go up. More metabolic activities in the body, right? Now, that is called hyperthyroidism. Have you heard that term? Hyperthyroidism. Your thyroid gland is hyper, working more, producing more T3 and T4, right? So, metabolism in your body will be high, even when you are resting, right? You are in sitting condition, resting condition, metabolism is high because of more secretion of T3 and T4 in hyperthyroidism. Okay? Now you tell me, if metabolism in your body is always high in hyperthyroidism, what kind of changes you will see in the body? Your heart rate will be high. You know, when metabolism goes up, like when you do exercise, metabolism goes up, right? Right? So heart rate, blood pressure goes up, heart rate goes up, right? How about heat? Heat will be produced in the body, right? So if you touch the body of that person, you will feel it's warm, warmer than normal people, okay? So, body is warm, high activity of the heart rate will increase, blood pressure will increase, right? Muscle tone will be more, and the person, if it continues for a long time, then what will happen? The fats will be used up more, right? More metabolism uses more, breaks more fat, right? So the person will lose the weight, will be skinny, will lose body weight, right? So those are the symptoms of hyperthyroidism. So if you just keep one thing in your head, like, you know, metabolism will go up, then you can think that what kind of changes will occur in the body, right? So hyperthyroidism causes those symptoms. Opposite is hypothyroidism. One is hyperthyroidism that I just explained. More secretion of T3 and T4 due to overactivity of the thyroid. Hypothyroidism is opposite. So the heart rate will go down, the blood pressure will go down. If you touch the skin of that person, kind of cold, chill, right? And because metabolism is low, okay? And more fat will accumulate in the body because less breakdown of fat, right? So those are the signs of hypothyroidism. Just opposite of hyperthyroidism. In hyperthyroidism, since the metabolism is high, the person will also have sleeplessness less sleep. Okay, always like body is kind of excited, right? So less sleep, sleeplessness, and eventually the person will get what? Easily cranky, easily will get irritated, hyper irritability. Okay, so those things will occur in hyperthyroidism. Yes.
The T3 and T4, they do the same job?
Very similar. They are very, very similar. Yeah. Only the difference is 3-iodine and 4-iodine, but they work very similar. Okay. So here you see the thyroid gland, 2 lateral lobes. This is the isthmus sitting in front of the trachea. Lobes are on both sides of the trachea. If you make a cross section, these are the follicles. In the wall, you have the follicular cells. In between, you have the parafollicular cells. Okay? And that is the thyroid. Now, T3 needs 3 iodine atoms and T4 needs 4 iodine atoms, right? And iodine binds with an amino acid that is called tyrosine. And iodine and tyrosine together form T3 and T4. In case of T4, which is also called tetraiodothyronine or thyroxine, 2 iodine binds with 2 tyrosine, amino acid tyrosine, binds with 4 iodine atoms, tetra. In case of T3, 2 tyrosines bind with 3 iodine atoms. So in both cases, 2 molecules of tyrosine, amino acid tyrosine, bind with either 3 or 4 iodine atoms. Okay. Inside the follicles, you have a colloid, protein colloid, that is called thyroglobulin. It is a glycoprotein, colloid of protein. What kind of protein? Glycoprotein. Okay. Its name is also, it is also called thyroglobulin. Makes sense? You know, globulin is one type of protein. Albumin, globulin, you already know, located inside the thyroid follicles. Thyroglobulin. Okay. Now, the amino acid tyrosine. Amino acid is a protein, you know, protein molecule. So tyrosine is present in this thyroglobulin. So you have tyrosine here in the thyroglobulin. Okay. So T3 and T4 are produced here. Iodine and tyrosine binds to produce T3 and T4, and that is secreted out. Okay. Now, just know that the follicles are filled with that protein, glycoprotein called thyroglobulin. And if someone has lack of iodine in the food, if you don't get enough iodine rich food, then what will happen? T3 and T4 will not be produced, right? If you don't have iodine in the body, then iodine will not bind with tyrosine. Is it clear? So, the tyrosine will start to accumulate more here because they are not being used up. Make sense? And these follicles will get bigger because more tyrosine will present. If these follicles, all these follicles get big, then the whole thyroid gland will get bigger. Make sense? So if you don't take enough iodine, then T3 and T4 will not be produced, right? So the protein will, tyrosine will start to accumulate inside the follicles, and follicles will get bigger. The thyroid gland will get bigger. Make sense? Because of lot of thyroglobulin inside it, and that is called goiter. Goiter is a condition in which the thyroid gland enlarges, enlargement of the thyroid gland. Okay. Have you seen any goiter patient? Anybody?
Yeah.
You saw it? Yeah. So if you go to like here, you don't see many. Almost no, because we have iodine-rich food, right? But if you go to third world countries or those countries, kids don't get enough iodine-rich food. A lot of tyrosine accumulates inside the thyroid follicles, and you will see the kids very often. You will see that they have got enlarged thyroid gland. Okay. Now, if you give them enough iodine-rich food or iodine, tyrosine will be used up to produce T3 and T4, so it will shrink. Small. You see here, this boy got goiter, enlargement of the thyroid gland. Hypersecretion. If T3 and T4 are not produced, less secretion will occur, will start to accumulate inside the follicles. So that is one clinical condition related to less thyroid hormone production and secretion. Another clinical condition that occurs due to hypersecretion of thyroid or in hypothyroidism, that is called myxedema. In myxedema, what happens, if you see the patient of myxedema, the face is puffy, like edematous face, soft and puffy, and around the eye you will see puffiness, like swelling around the eye, as well as the skin. If you touch the skin is cold because hypothyroidism, right? Less secretion of thyroid hormones. I talked about that. So skin is cold and dry, very dry skin. So those are some symptoms of myxedema. Prolonged hypersecretion of thyroid or hyperthyroidism, if it continues for a long time, that leads to a clinical condition that is called Graves' disease. Okay? Graves' disease. And in Graves' disease, the person will be what? Very skinny, right? Because hyperthyroidism, prolonged hyperthyroidism, right? Fats have been used up. So the person will be skinny, thin, always, it's kind of, restless and irritable. And another thing is interesting, that behind the eyeball, fat accumulates in the orbital fossa. Now you just think that if behind your eyeball, inside the orbital fossa, more fat accumulates, then what will happen? The fat will push the eyeballs outwards, right? So if you look at that person who has Graves' disease, you will see the protruded eyeballs, like eyeballs are coming outwards.
Is that due to hypersecretion or
Hypersecretion. Although in the body, the fat amount will be reduced, right? The person will be skinny, but in some locations, fat will accumulate more. So this is kind of, interesting. Abnormal distribution of fat will occur. Okay? So, calcitonin lowers the calcium in the blood. Just know that, we'll talk about that later. Behind the thyroid gland, if you see the back of the thyroid gland, you will see 4 to 8 small glands attached to the back of the thyroid. Those are called parathyroid glands. And parathyroid glands are very important. Attached to the dorsal surface or posterior surface of the thyroid lobes. And they are 4 to 8 in number. The number varies person to person. These glands are very important. Why? Because the hormone produced by these glands is called parathyroid hormone or PTH, also called parathormone. Same thing. PTH, parathyroid hormone or parathormone. Why this hormone is very important? Because this hormone just works opposite of this. This one lowers the calcium, remember? And this one does what? Increases the calcium. Very important in the blood. Make sense? So you see, thyroid hormone calcitonin lowers the calcium. Parathyroid hormone increases the calcium. So I can tell that by the action of these two, your blood calcium is maintained. Is it clear? So if calcium tends to go up, which one should be released? Which side? One person is answering. Okay, so if calcium goes up, which one should be released more? Calcitonin to lower it, right? If blood calcium tends to go down, PTH should be released, right? So to move it up. So by the action of these two, your blood calcium is regulated. Now remember, this is very important. Your blood calcium concentration must be within this narrow range, 9 to 11 milligram per 100 milliliter of blood. Okay? This range is very important, 9 to 11 milligram calcium concentration in the blood. If the calcium in your blood goes above 11, that is called hypercalcemia. Hyper means what? More, right? Hypercalcemia. If calcium in your blood goes below 9, that is called what? Hypocalcemia. Make sense? Both are dangerous. Remember, calcium must be maintained concentration within between 9 and 11. Okay? Lower is not good, higher is also not good. Okay? Hypercalcemia is not good, could be dangerous. Hypocalcemia could be even more dangerous. Okay? So, very important. You see, this is the back of the thyroid, so these are the parathyroid glands. Okay? Now, how the parathyroid gland increases the calcium in the blood? Parathyroid hormone works on 3 areas, works on 3 organs. So PTH, parathyroid hormone, we know that it increases the calcium in the blood. How? Parathyroid hormone works on the bones, works on the kidneys, and works on the intestine. Now, inside the bone, you have a giant cell. You remember what's the name of that cell? Osteoclasts. Remember that? Osteoclasts love to destroy the matrix, right? And matrix contains a lot of calcium. So osteoclasts, if osteoclasts become active, they do what? Destroy the matrix, right? And release the calcium from the bone. We talked about that. So, what happens? Parathyroid hormone works on the bones to do what? Increase the osteoclast activity. stimulates the osteoclasts, right? So when the osteoclasts get like hyper, they will do what? Destroy the matrix of the bone, right? And matrix has a lot of calcium in the bone. So calcium will get out from the bone. Is it clear? So more osteoclastic activity means more release of calcium. More release of calcium from the bone. And this calcium will enter into the blood. So blood calcium will go up. Is it clear? Okay. So I'll ask you. Number 2, parathyroid hormone works on the kidneys. So now you tell me, you already know that parathyroid hormone increases the blood calcium, right? So simple, just think simple. Parathyroid hormone should let the calcium get out through urine or try to keep the calcium in the body. Keep it in, because it increases the calcium, right? It should not let the calcium get out through the urine, through the kidney. Is it clear? So parathyroid hormone works on the kidneys and prevent the loss of calcium through the urine. That is called the reabsorption of calcium, keeping the calcium inside. So that term is called reabsorption. Increases reabsorption of calcium. So kidneys will preserve the or retain the calcium, will not let the calcium get out through the urine. So blood calcium will go up. The last one on intestine. Parathyroid hormone does not work directly on the intestine. Parathyroid hormone does what? It produces vitamin D. And vitamin D works on the intestine. Okay? And vitamin D does what in the intestine? It helps in the absorption of calcium from the food we eat. So very simple. Parathyroid hormone helps in the synthesis of vitamin D, and vitamin D works on the intestine. Okay? And what it does, it absorbs the calcium from the food you eat. So if more vitamin D, more absorption of calcium from the food you are eating. Is it clear? So more absorption means more calcium will enter into the blood from the intestine. Will be taken into the blood more. So blood calcium will go up. So all these 3 actions together increases the calcium in the blood by the parathyroid hormone. Okay. Now calcitonin lowers the calcium. You know that, just opposite of this. Calcitonin works on these 2, not this one. Okay. So calcitonin lowers the calcium. How? Just working opposite of these 2. Inhibits the osteoclasts. Osteoclast activity. So you tell the osteoclast that you don't need to work. You keep quiet, okay? Don't break the matrix. Don't release the calcium, okay? So you sleep, okay? So just opposite of this. So calcium will not be released from the bone. So blood calcium will go down. Kidneys, will tell the kidneys, excrete calcium, okay? With the urine. Let the calcium get out through the urine. Make sense? So prevents reabsorption. Prevents the absorption. That means will not retain the calcium, will let the calcium get out with the urine. So the calcium in the blood, in the body will go down. Okay? So that's how the calcitonin works. It doesn't work on the intestine or vitamin D. So PTH does one extra thing here. Other two are just opposite to each other. Okay? Okay. So those are two important hormones that regulate the calcium in the blood. So now if you see this picture, you will easily understand. You see on the bone, on the kidneys, on the intestine. Okay? So now you understand if hyperparathyroidism, your parathyroid glands produce more PTH, then calcium will go up, right? And that can cause some problems. I told you that both hypercalcemia and hypocalcemia are dangerous. They are not good. Okay? That's why calcium should be maintained in that narrow range, 9 to 11. So hyperparathyroidism will break the bone's matrix more because we'll activate the osteoclast, right? You already know. Osteoclast will be hyper. So it will break the matrix of the bone. Now you tell me, if you break the matrix of the bone, you break a lot of matrix of the bone, then bone will be weak or strong? Weak. Because matrix gives the hardness of the bone, you already know, right? You have learned that before. So matrix gives the hardness. So the bones will get soft and weak. Deformation of the bone will occur because of the breakdown of the matrix by osteoclasts that I explained you here. Increased calcium in the blood depresses the nervous system, which is dangerous, right? Your nervous system is a very important system in the body. So if nervous system is depressed, then a lot of control functions of the body will be slower. Make sense? If your nervous system is depressed, your whole body activity will be slower. Right? So that is another thing. And if the calcium gets out from the bone more, calcium enters into the blood, so blood level of calcium is high, and that calcium will tend to accumulate in the kidneys, inside the kidneys, some locations in the kidneys. And calcium accumulation will cause what? Formation of stones. Calcium, if starts to accumulate slowly and eventually will form what? Stones in the kidneys, particularly in the kidneys. That all this makes sense, right? Now, hypoparathyroidism will lower the calcium in the blood, right? Hypo. So blood calcium will be low, and that is even more dangerous because lack of calcium in the body will cause convulsion, seizure, tetany, that's like seizure or convulsion or tetany, and paralysis of the muscles. And if respiratory muscle paralysis occurs, the diaphragm, very important respiratory muscle, diaphragm helps you to breathe, right? Also the intercostal muscles here. So those are respiratory muscles. So when the respiratory muscle paralysis occurs, then what happens? Death. The person will not be able to breathe, right? So dangerous, hypocalcemia. So hypoparathyroidism will result hypocalcemia, low calcium in the blood. Hyperparathyroidism will cause hypercalcemia, calcium, elevated calcium in the blood. So that is all about thyroid and parathyroid and their hormones. Now, another very important gland sitting on the kidneys. Those are called the adrenal glands. Remember that? So, on the kidney, you have the adrenal gland, like the crown of the kidney. Okay? So, this is the adrenal gland. So, how many adrenal glands you have? 2, because you have 2 kidneys, right? So, 2 adrenal glands, also called suprarenal glands, sitting on the kidney, supra, above. Now, if you cut this gland and see inside, it has 2 parts. The outer part, this part, is called the cortex, adrenal cortex, and inner part is called the medulla. So this inner part is the adrenal medulla. Okay? Outer cortex, inner medulla. Make sense? If I cut it, you can clearly see 2 parts inside. Now, the cortex, if you see the cortex, it has 3 layers in the cortex. How many layers? 3 in the cortex. This is 1, 2, 3. 3 layers of the adrenal cortex work as 3 separate glands. 3 separate glands. Make sense? That's why adrenal cortex is called 3 glands in 1. 3 glands in 1. Make sense? Very important, these 3 layers. This gland is extremely important. So, you need to know the name of those 3 layers and what kind of hormones they produce. They produce 3 different types of hormones. That's why I said 3 glands in 1. Okay? And medulla produces another type of chemicals. So we'll talk about that. Okay? So first you got some idea that adrenal cortex has 3 layers and they work as 3 different glands. What are those 3 layers? 3 layers are zona glomerulosa, zona fasciculata, and zona reticularis. Okay, you need to remember these names. Zona glomerulosa is the outer one. Okay, then zona fasciculata is the middle one, and zona reticularis is the innermost one. Okay. Zona glomerulosa produces mineralocorticoids. The hormones are called mineralocorticoids. Cortical hormones, corticoids. Cortex. Mineralocorticoids. The mineralocorticoids regulate minerals. That's why called mineralocorticoids. Minerals in the body. Sodium, potassium, other minerals. Okay? Just know that regulation of minerals. That's why called mineralocorticoids. Zona fasciculata, middle layer, produces the hormones. Those are called glucocorticoids. Glucocorticoids. Glucocorticoids increases the blood sugar, glucose in the blood. Is it clear? Glucocorticoids increases the blood sugar or glucose. Zona reticularis, sex hormones. You know that ovaries and testes, right, gonads produce sex hormones. But this layer of the adrenal cortex also produces sex hormones. Make sense? So those 3 layers produce 3 types of hormones, right? Mineralocorticoids regulate the minerals, glucocorticoids increases the glucose, and sex hormones. Now, I'll just mention name of one hormone of mineralocorticoids. The most important mineralocorticoid is called aldosterone. Most important mineralocorticoid, okay, is the aldosterone. Most important glucocorticoid is called cortisol. This is the most important what? What? Difficult name, right? Glucocorticoid. Most important glucocorticoid is called cortisol. Cortisol increases the blood sugar, blood glucose, right? Because it is glucocorticoid. Make sense? Does it make sense? Okay. So, because it is most important glucocorticoid, and I mentioned that glucocorticoid increases the blood sugar, blood glucose. Okay. It has another very strong and important function, cortisol. Strong anti-inflammatory action. Strong what? Anti-inflammatory function. Anti-inflammation. Now, you will probably you have heard when you get inflammation or inflammation in your conjunctivitis, eye, or any inflammation in the skin, you get a ointment that is called hydrocortisone. Have you heard that? Hydrocortisone? In Walgreens, everybody goes and buy the drop, or inside the nose, the drop hydrocortisone. Like 1%, 2%, very weak, right? But that has strong anti-inflammatory action. If you put hydrocortisone, the inflammation goes right away pretty fast, quickly. Hydrocortisone is artificial cortisol. Okay, so hydrocortisone is actually cortisol. Cortisol is natural. Hydrocortisone is same thing, artificially made. Make sense? So it has strong. If you put that drop in the eye, most of the eye drops are hydrocortisone. Just a quickly, you see the change. The inflammation goes out. Okay, so strong anti-inflammation. Sex hormones. We know the functions of the sex hormones. We'll talk about that in the last part today. So just know that 3 layers in the cortex. Now the medulla, the innermost part. The medulla is also very important. Why? Because medulla produces 2 hormones. Adrenaline and noradrenaline. I believe all of you have heard this name, adrenaline. Have you heard that? So, adrenaline, it's sometimes you'll see in the movie box, the DVD box or movie, box. You'll see this movie has a lot of drama, suspense, action. Will increase your adrenaline in the body, right? So adrenaline is the hormone that produces excitement in the body. Make sense? So important. Fight or flight response of the body, that is also adrenaline secretion increases suddenly in the body, right? So produces excitement in the body. Noradrenaline has very similar action. So just know that adrenaline and noradrenaline, they causes excitement in the body. So that is the adrenal gland. Adrenaline is also called epinephrine. If you hear the name epinephrine, same thing, adrenaline. And Noradrenaline is also called norepinephrine. More clinical. So here you see the cortex, 3 layers, and the medulla. Now, hypersecretion of adrenal cortex. If secretion from the adrenal cortex increases, that hypersecretion of adrenal cortex may lead to a clinical condition that is called Cushing's syndrome. Cushing's syndrome. And I'll just mention a couple of changes that occurs you will see in Cushing syndrome. One is called moon phase. So Cushing's